is my Apple pencil? Oh, it's here. Let's start. Ready? Let me share this screen with you. Oh, this is geometry. So you will take that course in future semester. Let me write the date. Today's Friday, November 13. Let me remind you what we did yesterday. So use the notations of differentials to write the approximate change in fx equal to 5 cosine square x given a small change dx. Okay, so what do you do here? Well, at the very end of the last class, we learned that differential dy is what? Derivative of x times dx. You know, when I was a student like you, this is what I used to do to remember. Let's say y equal to fx be a function. Okay, y equal to fx is a function, and the derivative with respect to x. What do you get? Yeah, prime of x multiply both sides by dx. That's how I used to remember. But that's not correct though. Dy over dx is not the breakable thing. That's one notation. So don't tell anybody that I told you, okay? But anyway, the differential dy is given by f prime of x dx. Okay, so then here it is, what's the derivative of 5 cosine square x? Well, you use the chain rule, don't you? 5 times, you bring 2 to the front, don't do anything inside, cosine function, and then derivative of cosine, which is sine x, don't forget dx. Okay, don't forget dx. So you can leave it here, but you know what? You are student of calculus. So what you can do here is, we have negative 5, what is left there? 2 cosine x sine x dx. Do you know what is this? 2 cosine x sine x. It is sine 2x, isn't it? So these are the things you should know. Okay, so that is what we were doing yesterday. And if you have any questions on that, please email me. We can meet in Zoom over the weekend also. Okay, if you have any questions. So far, I have got only one. I met only one of you over Zoom yesterday. So if you have any questions, email me. If I have time, I'm glad to meet with you and go over anything you don't understand. Okay, let's move on. Okay, let's move on. I'll send this to you, or send this somehow, so you'll get this. Let's move on. Now we have another section. Are you all listening to me? Wake up, wake up, wake up. Guys, good.
We're awake.
Good. Get some coffee. Something called L'Hopital's rule. Okay, something called, so when I'm talking loudly, I'm excited, not rude. Okay, something called L'Hopital's rule. Okay, so what does this do? Well, look, how do we, so we started, so you started talking about function, then limit, then continuity, then derivative. Now we go, then applications of derivative. Now we go back to limit again, L'Hopital's rule. Okay, something called L'Hopital's rule. So let me remind you, or find the, or evaluate the limits. Number one, say limit x approaches to 1 of x squared minus x divided by x squared minus 1. How do you do this? Guys, how do you do this? You could, yes, you can factor this. Well, if you plug in 1, what happens? If you plug in 1, what happens? Look, if you plug in 1, you have 1 minus 1 in 0 in the top, that is fine. But you also have 1 minus 1 in the bottom, so you have 0 over 0. If you plug in 1, you get 0 over 0. Factor, then plug in. Yes, you mean, let's see, Austin. Yeah, you could factor the bottom, also the top. Isn't it? We can factor both top and bottom. In other words, simplify algebraically, right? Yes, so is that right? So what we do, limit x approaches to 1. So in the top, you can factor x. What is left? X minus 1. In the bottom, what do you get if you factor x squared minus 1? Do you remember this formula? X squared minus a squared, difference of square. That is x plus a times x minus a. So you can think x squared minus 1 is x squared minus 1 square, which gives us x plus 1 times x minus 1. Okay, these are the small things you have to remember that helps you to speed your work. Okay, so in the bottom we get x plus 1 times x minus 1. Now we can divide x minus 1 in the top by x minus 1 in the bottom. Why? Because, so x approaches to 1 doesn't mean that means x is very close to 1, right? X is very close to 1. If x is 1, then we cannot do this. We cannot divide by 0. If x is 1, we cannot do this. So you have learned this in that whatever section, that limit section. But x approaches to 1. X is very close to 1. So x minus 1 is not 0. And then you are right. We get here x over x plus 1. Can you plug in 1 now? Can you plug in 1 for x now?
Yeah.
Yes, right? What do you get? 1/2. So don't always, so here's one very important thing. Don't always try to find answer. Always know what you are doing. Why this method works, why this method doesn't work. Okay, so yes, that's what you do. That's what you do. Uh, and do you remember this limit? Sine x over x. Mm-hmm. Do you remember this limit? Guys? 1. That's right. How did you do this? Did you use the table? X approaches to 0 from the left. X approaches to 0 from the right. So what are the possible values for x then? Negative 0.001, something like that, right? I think that's what you did. If you plug in those numbers and gradually moving toward 0 from both sides, the values of the function sine x over x, they get closer and closer to 1. That's right, it is 1. Let me do one more. Just for the practice at home, can you try to find out this limit? X cubed plus x squared minus 2x divided by x minus 1. Can you work on your piece of paper with pencil? I'm also working here, but don't look at mine, okay? Let's work in separately. I got 3. Did you get the same thing?
Yeah.
Good.
Yes.
Good. Any questions so far? Any questions so far? No question? Okay. Then let me use this small space here and write another problem. Limit x approaches to 1 of natural log of x divided by x minus 1. What do you do here? Do you know what is natural log of 1? You can leave your answer in the chat box. Do you know what is the natural log of 1? 0. Good. We can have 0 in the top. Okay. What about if you plug in 1 for x, what do you get in the denominator? Now there's a problem. Okay, now there's a problem. So 0 over 0. Again, 0 over 0 is not 1. It's not like 5 over 5. Okay, so can you simplify this? So just by plugging 1 for x, it doesn't work, right? It doesn't work. Can you simplify this? I don't think so. No, I don't think so. What do? Not much. Okay, so you know what? So now we have a situation. In the previous problem 1 and 3, especially in 1 and 3 here, although we could not plug in number 1, we could not plug in 1 for x, but we simplified that function algebraically and we got x over x plus 1, and then we could plug in 1 for x. That is perfectly fine. In number 3, we did the same thing. We couldn't plug in 1 for x initially, but what we did, we simplified that function algebraically and we got x times x plus 2. Then we plug in 1 for x, we got the limit. Okay, now number 4 is different. We cannot plug in 1 for x, right? And we cannot simplify that further. Are you all following me? What do we do? How do we find the limit of such a function? Okay, so how do we find such a limit? The answer is given by this L'Hopital's rule. Okay, the answer is given by L'Hopital's rule. So first, before we talk about this L'Hopital's rule, so any form like this, you see here, 0 over 0 or infinity over infinity, or in particular, well, let me just put infinity over infinity. They are called indeterminate form. They are called indeterminate form. Zero over zero, infinity over infinity. They are called indeterminate form. Now, so if you are dividing a non-zero number like 5 by 0, we call that it doesn't exist or it's not defined. But if you have 0 over 0 or infinity over infinity, it's called indeterminate form. Okay, let's move on. Indeterminate form. So I'm talking about limit x approaches to, let's say, limit x approaches to 0 of ex minus x minus 1 divided by x squared. Well, if you plug in, if we plug in x equal to 0, we get what? If the power 0 is 1, we get 0 over 0. Plug in 0 for x in the top and bottom, we get 0 over 0. Indeterminate form. Indeterminate form. Similarly, take another example. Let's say limit x approaches to infinity of 4x cubed minus 2x squared plus 1 divided by 8x cubed plus 5x squared minus 2. Now, when that means what? When x is getting larger and larger, when x is getting larger and larger, what happens to the top? it gets larger and larger, even faster than x. So x approaches the numerator means this guy here also approaches to infinity, and so does the denominator. So we have here a situation of infinity over infinity. That's also another indeterminate form. So these are the situations. These are the types of problems in which we use L'Hopital's rule. Do you understand this? Do you want to ask any questions?
So if it's either 0 over 0 or infinity over infinity or negative infinity, then it's indeterminable form.
Indeterminate form, yes, and we can use L'Hopital's rule in such a situation, right? But we have more forms which I'll tell you later. But let's begin with this. If we have 0 over 0 or infinity over infinity or negative infinity over positive infinity or positive infinity over negative infinity, L'Hopital's rule. Okay.
All right.
Understand that?
Yes. Thank you.
Okay. Good. So, any other further questions? Good then. So, what is L'Hopital's rule then? Well, what is L'Hopital's rule? So your function is like this. Okay, your function is like fx over gx. Your function is fx over gx, a rational function. It doesn't have to be rational function. Let's say fx over gx rational. So you take the limit as x approaches to a. Okay, x approaches to a. So let me write a little differently here. So you have gx, okay, where when you limit of fx, the top one, is x approaches to a 0 and is also 0. Okay, so we have 0 over 0 condition here, indeterminate form. If that happens, then the limit of fx over gx, is x approaches to a, is same as, you see here, the same as limit of the derivative of fx divided by derivative of gx. Now, be careful here. We are not finding the derivative of fx over gx. We are not using quotient rule. It is just the derivative of top divided by derivative of bottom. So that is L'Hopital rule. Or if you have infinity over infinity, or if you have infinity, when you take the limit of fx over gx, if you get infinity over infinity, then that is same as limit of f prime x over g prime x is x approaches to a. Do you understand this? We'll do some examples, don't worry. So then let's go back here. Look at number one. So, well, this is, so we can apply L'Hopital's rule here because we have indeterminate form, correct? So if you do that, what do you get? Let us do is equal to L apostrophe S, just to note that we are using L'Hopital's rule. This is same as what? Limit x approaches to 1, limit x approaches to 1 of what? You tell me. In the top, what do you have? Derivative of x squared minus x is 2x minus 1. In the bottom, it is hold on, maybe are you there? 2x in the bottom. Good. So that's what I was waiting. So good. So now, okay, that's what we get from L'Hopital's rule. Now, can you plug in 1 for x to find the limit? Now it's a regular limit here. Can you plug in 1 for x to find the limit? Yes or no? Yes, right? If you do that, it is 2 times 1 minus 1 in the top, and 2 times 1 in the bottom. So 2 times 1 is 2 minus 1 is 2, 1. You see here, we get the same answer. We get the same answer. Similarly, number 2. So if you plug in 0 for x, what happens? Or if you take the limit of sine x in the top, what do you get? Sine 0 is 0, 0 in the bottom. It is another candidate, another problem where we can apply L'Hopital's rule. So then, by L'Hopital's rule, when x approaches to 0, derivative of sine x is cosine x divided by derivative of x is 1. So we just have cosine x now. How do you find the limit of cosine x as x approaches to 0? Can you plug in 0 for x? We can. Cosine 0 is 1. Look, we got the same answer. Are you following me? Then number 3. Look at number 3. So again, in number 3, if you find the limit of x cubed minus x squared minus 2x, that's a polynomial function. To find the limit as x approaches to 1, you can plug in 1 for x. If you do that, you get 0 in the top. Similarly, you get 0 in the bottom, indeterminate form. Well, instead of simplifying this and doing this way, you can just apply L'Hopital's rule. If you do that, what do you get? Limit x approaches to 1, derivative of top is 3x squared plus 2x minus 1 minus 2, isn't it? Derivative of top. And derivative of bottom is 1. So it is just limit of x approaches to limit of 3x squared plus 2x minus 2 is x approaches to 1. So you can plug in 1 for x. What do you get? 3 plus 2 minus 2. That is just 3. That's what we got earlier. Can you have a look at this and see if you can, process this, understand this?
question.
Please go ahead.
So what are the conditions that need to be met in order to use this rule?
Okay, so that is you should have so you should have either 0 over 0. There are more. We'll go over that. For now, just stick with these two things: either 0 over 0 or infinity over infinity. Okay, either 0 over 0 or infinity over infinity.
All right.
So I give you two examples here. Let's call this example 3, 4, 5 here. Okay, so let's say find the limit of x is square plus x minus 6 divided by x minus 2. Can anybody tell me whether we can use L'Hopital's rule here or not? If you find the limit of top x squared plus x minus 6 is x approaches to 2, how do you do this? You plug in 2 for x, right? Or simply just say, if you plug in 2 for x, what do you get in the top, in the numerator? You get 0 in the top, and you also get 0 in the bottom, indeterminate form. Correct? Indeterminate form. So we can apply, we can apply L'Hopital's rule there. Okay, everybody, so we need to use the rule. Yes, so in this case we don't have to, in this in problem 5 we don't have to. You can simplify the top. So what do you get? You get x plus 3 times x minus 2, and cancel out the x minus 2 from top and bottom, and you can just, you don't have to use L'Hopital's rule, but we can use L'Hopital's rule here. Do you understand this? Because we have indeterminate form. Zachary? So let's use L'Hopital's rule. What does it tell us? Derivative of top, which is plus 1, divided by derivative of bottom, which is 1. Now we just have what? We just have, let me rewrite this again. We just have 2x plus 1, isn't it? Doesn't matter whether you put 1 in the bottom or not. How do you find this limit? Plug in 2 for x. What do you get? 2 times 2, 4, plus 1, 5. You get 5. Again, you don't have to use L'Hopital's rule here. You can also do here. You don't have to use L'Hopital's rule. So for example, you can simply limit x approaches to 2, factor the top. What do you get? X plus 3 times x minus 2 divided by x minus 2. X minus 2 cancel out. So what is left? So it is 5. You can do that also. Do you understand this? Now, let me give you another problem. Similar problem. How about, can you see this? limit x approaches to 2, x is squared plus x minus 6 divided by x plus 3. So hold on, guys. So just hold on, okay? This so crowded there. So let me go back to this. I think you need to understand this. So limit x approaches to 2, that is my 2, okay? Limit x approaches to 2 of x is square plus x minus 6 divided by x minus 2. So this is 0 over 0, indeterminate form. So we can, not we must, we can use the L'Hopital's rule. Okay? We don't have to. I just show you. We can just factor the top and bottom, and we can now look at similar problems. So number 2, x is squared plus x minus 6 divided by x plus 3. Okay, so x plus 3. How do you find this limit? Well, limit x approaches to 2. You factor the top again, x plus 3 times x minus 2, isn't it? So x plus 3 cancel out. What is left? What is the limit? Correct? Are you all okay with this? Limit is 2. Now try applying L'Hopital's rule here. Derivative of top, what is that? Guys,
2x plus 1.
x plus 1, derivative x plus 3 in the bottom. 1, so it is just what? Now, can you plug in 1 for 1? Can you plug in 2 for x to find the limit? Look what we got. So we get 0 when we simplify the rational function and find the limit. Now look what we got when we try to use L'Hopital's rule. Why? We should be getting the same thing, right? Anybody? Can you tell me why we got different answers?
Is it because when you first put in the x equals 2 to the original equation, it doesn't equal 0, 0. I think it equals like 0 over 5 or something like that.
Oh. Do you agree with your friend Christopher's answer? So do you, yes. So do you mean this is not a problem where we can apply L'Hopital's rule? Is that your answer? Exactly. Yes, Elizabeth.
Yes.
So you're right. So yes, you guys are smart. Yes, this is not the problem. So we cannot apply. The answer here is very good. So we cannot apply. We cannot apply L'Hopital's rule here because we don't have 0 over 0 or infinity over, we don't have that infinity form because limit x approaches to 2, of x squared plus x minus 6 divided by x plus 3 is not 0 over 0, not indeterminate form. Good answer, Elizabeth. Very good. So we have to be careful. Okay, so just to answer your question, some of you asked already when we can use L'Hopital's rule. So look, very similar looking problem, but we have to be careful when and when to use L'Hopital's rule, when we can use L'Hopital's rule, and when we cannot use L'Hopital's rule. So for what is that? For this problem, look at here, x squared plus x minus 6, x divided by x minus 2 is x approaches to 2. We can simplify the function and find the limit like we did in chapter 2, or we can use L'Hopital's rule, right? So we don't have to use L'Hopital's rule there, but so how about limit x approaches to 1 of limit natural log of x divided by x minus 1? Do you have any other option here? Yes, we can make the table of values, but that takes time, so we can simplify this further, right? We can simplify this further, and if you plug in 1 for x, well, it is a good candidate to apply L'Hopital's rule. So why don't we use this? Correct? Why don't we use this? So again, in number 1 here, this problem, we don't have to, because we can simplify this algebraically and find the limit. In number 2, we cannot use L'Hopital's rule because it is not indeterminate form. In this problem, though, it is way easier to use L'Hopital's rule. So what do you do? Let me put L apostrophe H so that it tells us we are using L'Hopital's rule. What was it? Okay, so your friend Elizabeth, she asked a question. If we can use L'Hopital's rule when we have 1 over 0 or 5 over 0. I would like to answer your question by an example. Let's see if I can come up with let us do this problem first, okay? So limit x approaches to 1. Tell me the limit derivative of natural log of x. Do you remember that? One over x, right? And derivative of x minus 1 is 1. So what is left here? This is not L'Hopital's rule, but I'm just rewriting the function. Okay, 1 over x. So just plug in 1 for x. What do you get? 1. Right? So, okay. So to answer your question, let's see. Limit x approaches to 2 x squared plus x minus 1 divided by x minus 2. Okay, x minus 2. Now, so what is what is the limit of this function? Now, so if you plug in 2 for x, what do you get? 4 plus 2 6, 5/0. Can you use L'Hopital's rule here? Can we apply L'Hopital's rule here? Well, so think about the limit of this function without applying L'Hopital's rule. The function is not defined at 2, right? The function is not defined at 2. So this is in this. So this is in the. So can you see this? There is a vertical asymptote. There is a vertical asymptote. X equal to 2. Right. On the other hand, if you try to apply L'Hopital's rule, what do you get? 2x plus 1 in the top, 1 in the bottom. So you get 5. That means on this side you get, depending on x approaches to 2 from the left or right, your limit is infinity. But when you try to apply L'Hopital's rule, you get 5. So we must have that indeterminate form to apply L'Hopital's rule. There's a proof on this one if you want to see it, if you want to know. Section 4.7 in the textbook. So we ran out of time. Thank you for a lot of good questions and your participations, guys. Honestly, I enjoyed talking with you.